Hi everyone, welcome back to VRC Smarter channel. So today we are starting with the new chapter 2 solutions of your NCERT CBSE textbook, right? This is chemistry, right? So in that today we are going to see part 1 of this solutions, and today we are going to see about the introduction, types of solution, concentration terms. Okay, only we are going to see these things. So if you are new to our channel, kindly subscribe the channel and click the bell icon for notification. So follow our channel and kindly hit the like button if you like this video. So, and we have made previously the haloalkanes and haloarenes lesson, and we also have alcohols, phenols and ethers. So if you want to watch that, the links are provided in the description. You can go and check it out. Actually, the alcohols, phenols and ethers have not been completed till what I've given in the description. Simultaneously we do solution as well as alcohols, phenols and ethers actually. So let us see it now. Okay, so solutions is a very interesting chapter of your physical chemistry. It is coming under the physical chemistry, but it's very interesting chapter and easy chapter also. Okay, so let us see what is the introduction and all these things. Now let us get into the chapter solutions. So solutions means what? Solutions means what? It is a mixture. Simply you can say it is a mixture of things, right? It is a mixture of things. Okay, so see, I have given an example over here. Okay, I have given an example over here. What is this? Can you all identify what is this? This is sugar, right? What is this? This is water. Okay, now what you are going to do is, to the water you are going to mix the sugar. When you mix the sugar in the water, what you will get? You will get the sugar solution, right? You will get the sugar solution. That means when you are mixing two things, you are getting a solution. Not only mixing two things, if you are mixing three things, or if you are mixing four things, if you are mixing five things, whatever you mix, you get the solution. But what is the condition for becoming a solution is nothing but your solution that you are going to obtain, the mixture that you are going to obtain should be homogeneous. Homogeneous. If the mixture that you are going to have is going to be homogeneous throughout the substance, then it is going to be called as solutions. What do you mean by homogeneous? Homogeneous means it should have a uniform composition. Okay, see, whenever I mix the sugar in water, it's going to have a uniform composition. All the particles of the sugar will get mixed up with the water. All the particles of the sugar will get mixed up with the water, forming the uniform surface, and no residuals will be formed in that solution. Clear? No substrate or residuals will be formed in the solution. That case is called as homogeneous solution. And if you take the solution, it should be, I told, it should be the homogeneous of two or more compounds when you mix. Not only two compounds, if you mix more than two compounds also, it is called as solutions only. But we give different names to different types of solutions. But we are going to see only binary solutions. Binary solutions. What do you mean by binary solution? This is an example of binary solution. Binary in the sense two, right? Binary means what? Two. That means one solute mixed with one solvent to give the solution is called as the binary solution. That means only two components are present in a solution, that is called as binary solution. The complete lesson is going to deal with what? Binary solutions only. We are not going to see any other type of solution, right? Binary solution. Now, what the sugar is called as, now if you talk about the solutions are made up of two categories. One is going to be called as solute, another one is going to be called as solvent. So solute plus solvent gives a solution. So tell me, what is solute over here? Solute is sugar and solvent is water. What is the criterion for becoming a solute? What is the criterion for becoming a solute? So solute in a solution should be lesser in quantity. Lesser in quantity. Okay. But solvent in a solution should be greater in quantity. greater in quantity. Clear? So solute in a solution should be lesser in quantity. Solvent in a solution should be greater in quantity. If you just look here, water is greater. If you just look here, water is greater in quantity. So this is water, right? So this is water. So water is greater in quantity. Lot amount is present. But sugar, we are adding this much only. Compared to sugar, water is greater. So sugar is lesser in amount. Sugar or glucose, everything is same, lesser in amount. So now what happens is, when you are going to add sugar in water, sugar is going to act as a solute and water is going to act as a solvent. Clear? Any doubts over here? We learnt what is solute, what is solvent, what is solution. Solution is nothing but it is a homogeneous combination of two or more components. It's called as a solution. Solution has solute and solvent. So solute means it present in the larger amount, solvent is present in the smaller amount. And in this chapter, we are going to completely discuss about the binary solutions. Clear? Okay. So now let us move to. So our next topic is going to be types of solutions. So types of solution is, see, based on the nature of the solution, we have three different types of solutions. So first type is going to be gaseous solution. Gaseous solution. Okay, if your solution is going to be a gaseous solution, then surely the solvent is going to be gas. Then the solvent is surely going to be the gas. But solute can be liquid, or gas. Okay, if it is a gaseous solution, remember your solvent is always gas, but your solute can be solid, liquid or gas. So let me give an example for solid and gas. Camphor in nitrogen. For liquid and gas, you can give chloroform in nitrogen. For gas in gas, you can give an example of oxygen in nitrogen. So these examples are very important to remember. They can ask you, give an example for gaseous solution, means you have to give the example. Solid in gas, camphor in nitrogen. Liquid in gas, that means chloroform in nitrogen. Gas in gas, oxygen in nitrogen. Like that you have to give the example. Okay, next type of solution is liquid solution. So automatically you know what, if it is a liquid solution, then surely the solvent is going to be liquid. Okay, solvent is surely going to be liquid. Your solute can be solid, liquid or gas. Solid, liquid or gas. If very good example that I gave earlier is what, for solid and liquid, it is going to be glucose. Glucose in water is going to be the very best example of solid and liquid. Okay, it is a solid, right? Glucose is a solid mixed with liquid. Now, liquid in liquid. Liquid in liquid, very easily you can give an example. Ethanol. Ethanol in water is going to be the example of liquid in liquid. Gas in liquid. For gas in liquid, you can give an example like oxygen in water. When oxygen in water, when it is present in the sea. So for aquatic organisms, what happens? The oxygen dissolved in water is helpful for the aquatic organisms to breathe. So moving on to the solid solutions. Next type of solution is going to be what? Next type of solution is going to be solid solutions. Solid solution. If the solution is going to be solid solution, then solvent, usually solvent will be always solid, solid, solid. Where the solute can be solid, liquid or gas. Now, solid and solid, you can give an example, copper and gold. Copper and gold. Okay. So, actually when we are making the gold ornaments and all, it will not be of pure gold. Okay. It will not be of pure gold, because if you make with pure gold, it cannot be for present for long life. So, it will not be for made with pure gold. So, copper is added. So copper and gold can be an example for solid and solid solution. Then liquid and solid. There you can give an example. So amalgam of mercury in sodium. So what is the example? Amalgam of mercury in sodium is an example of solid solution. That is liquid in solid. Gas in solid. Gas in solid solution, you can give an example of hydrogen in palladium. Solution of hydrogen in palladium. Clear? So these are the types of solutions: gaseous, solid and liquid solution, and types of solute solvents you have to remember. And you also have to remember what are the examples that are present for these things. You have to remember that also. Okay. You should also remember the examples, and that is very important to remember. Right? Okay. So now we are moving on to the concentration terms. So what is all about the concentration terms that we are going to see means, see, concentration terms are divided into two types. Concentration terms are divided into two types. One is qualitative, another one is quantitative. What is the difference between qualitative and quantitative? Qualitative is nothing but, if you just want to speak qualitative, it is nothing but you speak the description about a solution. If you tell the solution is dilute, if you tell the solution is concentrated, it comes under the qualitative description of the solution. What is the meaning of dilute? Dilute, then you have to have more solvent and less solute. Less solute. If your solution is going to be concentrated, then you are going to have less solvent but more solute. More solute. Clear? So let us see, for example, I am taking two beakers. The beaker is completely filled with water. So both the beakers are having water. Now when I add 1 spoon of NaCl to it, the solution is going to be having NaCl component but less in amount. But here I am adding 3 spoons of NaCl. How many? 3 spoons of NaCl I am adding. That means the solution here is going to become little bit concentrated compared to the solution. So when you are adding more solute into the solvent, then the solution becomes more concentrated. But see, describing the solution in this way, the concentration description in this way is not going to be fair enough, because we have to give the exact concentration term. That means you have to give mathematically. So for that, you are going to read the quantitative description. It's very, very essential. So quantitative expression, and that you're going to learn about mole fraction, and you're going to learn about mass percent, volume percent. Okay, then ppm. Then you're going to learn about molality. These two are very, very important. Molarity and molality. Based on that, sums will be there. Based on mole fraction, also sum will be present. Mass percent, volume percent, mass by volume percent. Okay, so these are the things we are going to study under quantitative description. Clear? Yes. Now let us move on to the quantitative description. First, let us look after the mass percent. So looking after the mass percentage, so mass percentage can also be represented as W by W. This is also called as mass percent. So mass percentage is nothing but, you are just reading the formula. With the formula you can write the definition. So mass percentage is equal to mass of the solvent divided by total mass of the solution, total mass of solution into 100. Whenever you do percentage conversion, you just multiply it with 100, right? So mass of solvent into total mass, that is divided by mass of solution into 100. So the same you are going to write it in definition if necessary, because most of the times they will not ask you the definition. If you write the formula itself, they give the full mark for define mass percent. Mass percent is equal to number of mass of the solute divided by total mass of the solution into 100. If you write that in formula itself, they give you mark. Okay. Listen here. 10% of glucose in water. What is the meaning of it? That means 10 grams of C6H12O6. C6H12O6, that is glucose, is dissolved in 10. That is, always remember the total mass of the solution is going to be 100 grams. Always remember the total mass of the solution is going to be 100 grams total mass. Okay, so total mass of the solution is 100 grams. So then what is the meaning of it? 10% of C6H12 means 10 grams of solute is mixed in 90 grams of water. Water is solvent over here, right? So 10 grams of solute mixed in 90 grams of water is the meaning of 10% of C6H12O6 in water means 10 grams of C6H12O6 present in 90 grams of water. So next, one more application is given over here. So for making the commercial bleaching solution, you have to add 3.62 mass percentage of sodium hypochlorite in water. So for making the commercial bleaching solution, you are supposed to add 3.62 mass percent of sodium hypochlorite in water. Clear? Now you know what is the meaning of 10% of C6H12O6 means what? Not only C6H12O6, whatever the compound solute is given for you, 20% means 20 grams, 30% means 30 grams. Like this you have to calculate. Now moving on to the volume percentage. Volume percentage is also similar to mass percentage, but you use a component called volume over here. So your volume percentage is going to be equal to volume of the solute divided by the total volume of solution into 100. So volume of solute divided by the total, how much solution is the total volume of solution into 100. If you do, that is called as volume percentage. So you are taking 10% of ethanol solution. That means you are going to take 10 ml of ethanol. 10 ml of ethanol dissolved in 90 grams of, that is 90 ml of water. There 90 grams, here ml, because it is volume percentage. 90 ml of water is going to be called as what? 10% of volume by volume ethanol solution. 10% of volume by volume ethanol solution means what? 10 ml of ethanol solution dissolved in 90 ml of water. Here also one of the application is given. The solution of ethylene glycol is used as antifreeze in engines. Okay, that means this antifreeze means the meaning is nothing but when you add this solution of ethylene glycol, what happens is the engines, normally when you drive the engines, the engine will become hot. To cool the engine, this antifreeze is used. Okay, so actually antifreeze lowers the freezing point of the water. Okay, to 255.4 Kelvin. It lowers the freezing point of the water to 255.4 Kelvin. Okay, so these values are not necessary for board, but if you are going to write a need, then these values are important. Okay, just remember where the solution of ethylene glycol is used. So the solution of ethylene glycol, that is 35% of volume by volume. 35% of volume by volume ethylene glycol solution is used as an antifreeze in engines to reduce the freezing point. To reduce the freezing point of water to 255.4 Kelvin. This is the application of volume percentage. Okay, clear? Any doubt over here? Next we will move to ppm. So listen, ppm, that is parts per million, is also called as ppm. Okay, so actually the problems based on ppm will not be asked. They will not ask you to find ppm, but they can ask the definition of ppm. Okay, so what is ppm is nothing but ppm is equal to number of parts of the compound, number of parts of compound or component divided by total number of parts of the component, total number of parts of the component into 10 power 6. This is called as ppm. Actually, ppm is used to find the traceable amount of solute. Trace solute or traceable amount of solute. That means very small amount of solute is present in a solution. Then ppm is used to find those types of solution. Very small amount of solution is used to be found out with the help of trace solute. Clear? Trace solute means small amount of solution. You can find it using parts per million, ppm. Okay, and one more application of ppm is present. That is, when you are taking 1 ppm of fluoride ions. 1 ppm of fluoride ions is helpful for treating the tooth decay. So it is useful, right? So 1 ppm of fluoride ions is much useful. It is helpful for treating the tooth decay. But if you are taking 1.5, just 0.5 you are increasing 1.5 ppm of fluoride ions, it is going to cause malted teeth. That means the teeth damage will be created, as well as 1.5 ppm of fluoride ions rat poison. It acts as poison. It acts as the poison. So it is acting as the rat poison. Okay. Clear? So this is about the clear definition of parts per million. Okay. So now let us move on to mass by volume. Now we are moving to mass by volume percentage. So mass by volume percentage means first on the top you should have the mass, and on the bottom you should have the volume. Okay. So on the top you should have the mass, and on the bottom you should have the volume. That means, see, mass by volume is equal to mass of I'm leaving it blank for now, volume of. So percentage means for sure you have to multiply it with 100. So one more trick I'll give here, whenever you are writing that top, it should be of solute, bottom it should be of solution or solvent. So mass of solute divided by the volume of solution into 100 is the mass by volume percentage. So where this mass by volume percentage is used, that means application where it is used. It is used in medicine and pharmacy. It is used in medicine and pharmacy. So it is a mass of solute that is dissolved in 100 ml of solution. That is called as the mass by volume percentage. So used in medicine, used in pharmacy, in those areas it is commonly used. That is the application of it. Now moving on to mole fraction. So mole fraction is nothing but you are taking, so actually if you are taking the mole fraction is represented with the letter X. Mole fraction is represented with the letter X. So actually mole fraction, that is your X, of any component A. So for example, if you are adding the A component plus B component, A may be solute or solvent, B may be solute or solvent, that is not needed first. To give the solution C. So you are finding the mole fraction for A and mole fraction for B. If you are finding the mole fraction for A, then it is equal to number of moles of A. So number of moles usually represent with N. Number of moles usually represent with N term. So number of moles of the compound, whatever the compound you took, number of moles of compound divided by total number of moles of solution, that of N of A plus N of B. Understood? That means, see, first X is mole fraction. So a mole fraction can be found out only for solute or for solvent. For anything you can find the mole fraction. But if you are finding the mole fraction, then mole fraction of the compound should be equal to the number of moles of that compound which you are finding the mole fraction divided by the total number of mole fraction in a solution. This is what the formula for mole fraction. Then tell me now, what will be your component B, mole fraction for component B? It will be N of B by N of A plus N of B. Okay, I am giving you one example over here. See, they have given you two components. NaOH is one of the component. It's dissolved in H2 like that they have given. So NaOH is your solute and H2O is your solvent. Right? So clear. So NaOH is the solute and H2O is the solvent. Now they are asking you to find the mole fraction of all the components. Means the mole fraction of solute, that is NaOH, you have to find it separately. Mole fraction of water, you have to find it separately. If solute is A, you have to use this formula and find. Both are same only, right? So instead of A, you will put NaOH and you find the number of moles of NaOH and number of moles of H2O, and you will substitute in this formula. Okay, this is B. So now one more trick is there. So in a particular solution, how many ever the mole fraction you find, all the mole fraction, the sum of mole fraction will be equal to 1. That means, see here you have two solute and solvent. You are finding the mole fraction for the solute and solvent, then the mole fractions sum will be equal to 1. So from this you can easily find out. See, I am finding out if the number of moles, that is X of NaOH, if I find. So if I find X of NaOH, then I no need to find the H2O's value. I no need to find, because I know that X of A plus X of B is equal to 1. That means X of A I know, 1 I know. So I bring this X of A to this side, 1 minus X of A, then I will get X of B. Right? So in that way you can find the answer. So we will do the problems at that time, you will be clearly able to understand this one. Okay, the next video of the same lesson, we will solve the numericals based on the concentration terms. So we will solve the numericals based on mole fraction, molarity, all these things, because these are the important things. ppm, they will ask only the definition, they will not ask you to solve the problem. But where they will ask you to solve the problem is molality, mole fraction. These three are very, very important. So this only they will ask you to solve the problems. And mass percent, volume percent, you should know how to split the terms. Okay, that one. I told know how to split it. 10% given means how to split 10 grams into 90 grams like that. You have to know that. Next, molarity. So mark it with the asterisk or whatever, the important symbol, anything, because it's very important. So what is the definition for molarity? Molarity is represented with capital M. Molarity is equal to number of moles of solute by volume of solution in liters. Number of moles of solute by volume of solution in liters. This is an example of molarity. Okay, so that is a definition for molarity. Okay, definition for molarity is number of moles of solute by volume of solution in liters, means always a solution should be in liters. If it is not in liters, then you have to convert it into liters. Okay, or rearrange the formula in order to get the liters. Okay, so the unit of it can be written as capital M, molarity itself, or you can write mole liter inverse. Mole liter inverse. Okay, anything you can write, either capital M or mole liter inverse. Both are going to be the unit for molarity. Clear? Okay, so now you just see what is the meaning of 0.25 mole liter inverse is dissolved molar. What is the meaning of this? That means it's nothing but, see, molar of NaOH is given. Okay, 0.25 mole liter inverse of NaOH. What is the meaning of it is? That is 0.25 moles of NaOH. Moles of NaOH is dissolved in 1 liter. Is dissolved in 1 liter 1 liter solution. Okay, 1 liter solution. It may be, if it is water, then 1 liter of water. That is the meaning of 0.25 mole liter inverse. That means 0.25 moles of NaOH is going to be dissolved in 1 liter of solution. Clear? Right. So now you understood the meaning of molarity. So many problems will be asked based on the molarity, because molarity is a very, very important thing. So remember this one. Okay, this is very, very important to remember. Okay, this particular information is going to be very, very important. So now we are going to see the molality. So what is molality? Tell me. So molality is represented with a small m. This is also important. So molality is equal to number of moles of solute, but one change is going to be mass of the solvent. Mass of solvent, that should be present in kg. Mass of the solvent should be present in kg. So actually molality. So what is the meaning of molality? For example, see, molality, first let us write the unit. Unit can be written as small m or mole kg inverse. Mole kg inverse is going to be the unit of molality. So molality, if you are going to take, okay, so one molality of KCl. I am taking one molality of KCl. That means, see, 1 mole of KCl is dissolved in 1 kg of water. Dissolved in 1 kg of water. That is the meaning of it. Clear? Any doubts over here? Right. So one more important thing that you have to remember about molality and molarity. Okay, not only molality and molarity, all the concentration terms. Okay, one more important thing. Listen here. See, all the concentration terms like mole fraction, okay, mole fraction, molality, okay, mass percent, ppm. See, all these mass percent, all these are independent of temperature. All these are what? Independent of temperature. Okay, that means, see, mole fraction, molality, mass percent, ppm, these does not depend upon the temperature. Okay, when temperature change happens also, what happens? The change in the molality or mole fraction will not take place. Okay, they are what? Independent of temperature. They are not dependent upon the temperature. So molarity and volume percentage. These are temperature dependent. Temperature dependent. Okay, so molarity, volume percentage, or these are going to be temperature dependent. That means it is dependent upon the temperature. Based on the temperature it will change. Under the equilibrium temperature or under the standard temperature only it will give you the exact value. Okay, so molarity and volume are temperature dependent. Mole fraction, molality, mass percent, ppm are independent of their temperature. This one is very important and you have to note it up. Can be asked for 1 mark. Okay, so that's all for today's video. Thank you so much for watching this video, and without forgetting, kindly subscribe to our channel and click the bell icon for notification and follow our channel, and kindly like this video if you like it. And for this video, the next for this lesson, the next video is going to be based on the numericals of concentration terms, that is the numerical based on mass percentage. Okay, mass percentage, usually they will not ask the question. They will ask the question based on the mole fraction, molarity and molality. As well as they will give the mass percentage, and no, you have to split the mass percentage like this. They will be giving you 20% of mass percentage like this they will give. So if they give you like this, you have to split it as 20 grams of, for example, NaCl is given, means 20 grams of NaCl and 20 grams over, so 80 grams of water. Like this you have to split it out of 100 grams of there is total solution is 100 grams, like that you have to just split it. So for this purpose only we are reading the mass percentage. Okay, for this purpose, but they will not ask you to find out the mass percentage and all. Mostly the question will not be like that. Okay, so thank you so much. Meet you in the next video. Until then, bye.